Welcome to myprojectpesa.com. I am going to explain about the computer aided detection of ischemic stroke using segmentation and texture features. I am going to brief introduction about this process. We are going to develop a new method to detect the ischemic stroke using segmentation, midline shift and image feature characteristics. CT computer topography images are mainly using for diagnosis of ischemic stroke. So here we are going to implement 5 stages, namely pre-processing, segmentation, extraction of texture features and classification. Noise is filtered in pre-processing step. The features are extracted by GLCM, that is gray level co-occurrence matrix, and HOG histogram of gradient. SVM support vector machine and neurofuzzy amplers are used for classification purpose. After that, k-means clustering segmentation method is applied, and then finally quantitative analysis, that is accuracy, is determined. Main application of our proposed method for early detection of ischemic stroke is indicate to improve the efficiency and accuracy of the clinical practice. First, select the input image from the collected dataset. The next step is the pre-processing step. In pre-processing step method, median filter is used to remove the noise from the input images. It's often desirable to be able to perform some kind of noise reduction on an image or signal. Median filter is a non-linear digital filtering technique often used to remove noise. Such noise reduction is a typical pre-processing step to improve the accuracy results of the later pre-processing. Median filtering is very widely used in digital image processing. Here next step is the segmentation process. Here we actually extract the affected area from the image, the part of it which contains just the postcode. The goal of segmentation is to simplify or change the representation of an image into something that is more meaningful and easier to analyze. Next one is the feature extraction method. For feature extraction, here we used two methods, GLCM and HOG. First, we are going to discuss about the GLCM. GLCM is nothing but the gray level co-occurrence matrix. It contains information about the positions of pixels having similar gray level values. A co-occurrence matrix is a two-dimensional array in which both the rows and the columns represent a set of possible image values. GLCM is defined by the first specifying a displacement vector and counting all pairs of pixels separated by the having gray levels I and j. GLCM is defined by number of co-occurrences of the pixel. The co-occurrence matrix has the dimensions where n is the number of gray levels in the image. From the co-occurrence matrix is obtained, we have to extract the 12 different statistical feature. Then the next feature extraction method is HOG, that is histogram of gradient. HOG captures edge or gradient structures that are characteristics of local shape. Histogram of oriented gradients, an image descriptor based on the image's gradient orientations. We exactly only the mathematical value from HOG. HOG descriptor is based on dominant edge orientations. Image will be divided into cells. Then the next one is the classification process. In classification also we are going to use the two methods, that is SVM and neuro-ANFIS method. In this we classify the image whether it's frontal or not, whether it is affected image or non-affected image by using SVM. Support vector machine classifier. It also support vector networks or supervised learning models which associated learning algorithms that analyze data and recognize patterns used for classification and regression analysis. And then second one is the neuro-fuzzy ANFIS, that is artificial neural network system. This is also the supervised learning models. We're going to discuss about the implementation of this process. This is the MATLAB command window. These are the files used for this process. Modify main is the main function file. Others are the subfunction files. Click the modify main.m and choose the RIME file option. In dataset, choose any one of the images from the dataset. So from this first figure describe about the first figure is the input image, and the next figure is the pre-processed image. Then third figure is the midline image, that is outer region is segmented, and correctly the affected area part is segmented in the image. 3, 4, 5 is denoted as the segmented area, that is the affected area. And the fourth one is the extract features values. So we apply both the methods. Both the feature extraction method is applied and extract the features. In H4G feature extraction, mean, variance and skewness, good traces values also find. Then finally we calculate the features values and apply the classification process. For applying the classification method, we find out that given images, that is given input images, the normal or abnormal images. Finally from that we conclude that the ischemic stroke, that is the stroke region is find out from the input image, that is brain image, and also we conclude that the image is the normal or abnormal. Thank you.